In this video, you will learn about the relationships in 45, 45, 90 degree special right triangles. The triangle shown above is an example of an isosceles right triangle. Because we have the base angles that are the same, the two sides are the same. Now, if we want to derive the relationship for what y is, we can write an equation with Pythagorean theorem. So we could say x squared plus x squared equals y squared. Now we can combine the x squares as like terms. So it's 2x squared equals y squared. And then if we want to solve for y, so we can make everything in terms of x, I can take the square root of both sides. And this becomes y equals the square root of 2x squared. Now when we simplify this, this means that the square root of 2 times the square root of x squared equals y. The square root of 2 doesn't simplify, it stays the same. However, the square root of x squared becomes just x. So we can write the relationship as x root 2 equals y. So instead of considering this to be x, instead of considering it to be y, we can now consider this to be x root 2. And these are basic relationships for a 45, 45, 90 triangle. Now, generally speaking, these are all the relationships that we have. Sometimes it's helpful to see how the sides and the angles are related. In this example, we first can see that across from the 45 degree angles are the value of x. So we have a 45 degree angle. Across from it is the value of x. Additionally, across from the right angle is x root 2. So if we have our right angle of 90 degrees, across from it is the value of x root 2. You don't necessarily need to use these, but these can be helpful sometimes in setting up relationships. Now, if we want to find the value of a variable, we know from the last slide that across from the 45 degree angle is x, and across from a 90 degree angle is x root 2. In the first example that we have, the 9 is across from the 45 degree angle, so this is considered to be x. So in this case, we can say that the value generally here is x equals 9. Now the other two sides that we have are, this is also across from a 45 degree angle over here, so this is also x. And this side, the hypotenuse is across in the right angle, so it's x root 2. So if I want to fill this in, since x is 9, that means that this side length is 9, and this side length is 9 root 2. So the value of h is 9 root 2. For the next example, the given side length is across from the right angle. And we know that the one that's across the right angle generally is x root 2. Now if we use this to write an equation, this means that x root 2 equals 7 root 2. Now if we want to solve to find the value of x, what we can do is, we know that it's really x times the square root of 2. And in order to get x by itself, we have to eliminate the square root of 2. And the inverse of multiplying, or the opposite of multiplying, is dividing. So we can divide both sides by the square root of 2. So this square root of 2 cancels with that square root of 2. And on the other side, the root 2 with the 7 cancels with the root 2. So this means that the value of x is 7. Now if I go back to find the other side lengths, This side, u, is across from a 45-degree angle, so this is x. And this last angle is really 45 degrees, so across from this 45-degree angle is really just x. So since x is 7, that means this side length is 7, and the side length of v is 7. So we could say u equals 7, and v equals 7. Now, as we progress, we're going to continue to apply the same properties, but the algebra, or the simplifying with the radicals, becomes a little more complicated as we go. If we follow the same original setup, the side length we're given, 2 root 2, is across from a 45-degree angle, so this is x. So I could say that x equals 2 root 2. We're going to ignore this x for right now and just find the other side lengths. If x equals 2 root 2, the other two side lengths are, this is x because it's across from a 45-degree angle, and this is x root 2 because it's across from a right angle. Now this side length is 2 root 2, that means this side length is also 2 root 2, and this last side length over here is going to be, in order for it to be x root 2, it's going to be 2 root 2 root 2, because the 2 root 2 replaces the x. Now, if we have two radicals next to each other, this implies that we are multiplying. So it becomes 2 root 4. The square root of 4 is 2, so we get that our side length is 4. So our final side length in that special right triangle is 4. In this example, again, we're going to get rid of this x and just focus on finding the side lengths. The 6 is across from the right angle, so this means that our relationship is x root 2. So if we write an equation using this, we have x root 2 equals 6. Now to solve to get x by itself, this x is really multiplied by the square root of 2. So I have to divide both sides by the square root of 2. So we get x equals 6 divided by square root of 2. However, like we learned in our simplifying radicals section, we can't have a radical in the denominator. So in order to get rid of the radical in the denominator, we have to follow the process called rationalizing, where we'll multiply the numerator and the denominator by the square root of 2, which gives us x equals 6 square root of 2 divided by 2. And then finally, we can simplify because 6 divided by 2 gives us 3. So x equals 3 root 2. Now we can use this to go back and find the other side lengths. So we know that this side is across from a 45-degree angle, so this is x, and this is x as well. Meaning that the remaining two side lengths have a value of 3 root 2. In the next example, the side lengths that we are given are across from the 45-degree angles, meaning that they are both considered to be x. So if we use this one for example, we could say that x equals 5 root 6. Now if we apply this to the other side length that we are looking for, then we said this side is x root 2. So instead, if I want to use x root 2, instead of putting the value of x, I'm going to put the 5 root 6. So it becomes 5 root 6 root 2. Now this implies that we're going to multiply the radicals. So we get 5 square root of 12. However, like we always do with radicals, we have to make sure that we simplify. So if I simplify 5 square root of 12, it becomes 5 square root of 4 times 3. So it's 5 root 4 root 3. The square root of 4 is 2, so it's 5 times 2 root 3. So we get our final answer is 10 root 3 as our value of h.